just check here. Mahmoud?
Here.
Yeah. Gafar? Gafar?
Here.
Oh, here. Amjad? Sarah?
Here.
Where? Oh, there you are, yeah. Mo?
Yeah.
Daniel? Where's Daniel? Asleep? Savi? Yeah. Sabrina? No. Alfreda? Arya? Chidi? Yungpang? Amna? Mariam?
Here.
Yeah. Michelle? Abir?
Here.
Autumn? Okay. Celine? No? Sophia? Yeah. Mubarak? Shadera? Where are you? Mohammed?
Here.
Oh, Sabrina's gone. Mosa?
Here.
Angela? Ahmed? Safra? Neil? So, what? You confused me. So, I'm missing from this group Celine, Autumn, and Neil. I better write that down. Can I just borrow a pen for a sec there? So, Celine, Autumn, Neil, and from the other group, I'm missing Sabrina, and Daniel. Thank you. Yeah. Okay, guys, we'll continue now. Guys, we're continuing now. Hang on, no, we have to wait. Continue now. So, just something I forgot to point out in case there was some confusion. What was the first example I asked you to integrate? X sine x, wasn't it?
Yes.
And what did I say the answer was there? Was x cos x?
Minus x. No. We actually
X
did
sine x plus cos x.
We did x cos x, was it? Okay. X cos x, and what was that equal to?
X sine x
Yeah,
plus cos x.
Let's see.
plus cos x plus c. Now, sometimes they might put limits on this. So, of course, if they have limits, you don't need the c. But just so there's no confusion, the limit still applies to everything, okay? Because sometimes people might be confused. If they had something like fg minus integrate f derivative g dx, and I ask you to integrate this fg derivative dx, and I put limits here, yeah, there's limits here as well, but also on the other guy too. So in other words, the limits do go on all. So 2 pi goes into everything and 0 goes into everything. Okay? Otherwise, you have some silly situation where you have a piece with x in it and a number, which doesn't make sense because when you put limits into an integration, you always finish up with a number. Yeah? Did I give you any questions with limits?
Yes. Number 4.
Number 4? Number 3.
Yeah, sorry.
Yeah. Yeah, they were all 0 to 2 pi. All right. Anyway, I just wanted to clarify that in case there was some confusion. And we'll continue now with the next topic. So, next now, we're going to have a look at is volume. So integration is quite useful because one thing we've learned we can use integration for is if we have some shape, and if I mark off an A and a B, if I integrate from A to B, fx dx, what does that represent? It represents the area. And that's quite powerful because it means you can get the area of any irregular shape. Okay, you simply need to know the function that makes the shape, and you can get its area. It's quite useful. Now, you can also use integration to get volume, but volume in a very particular way. So I'll just draw again. Let's imagine I have a simple curve like this. That's fx. And then we'll say there's A and there's B. Now you might say, well, how do I get a volume out of this? Because it's still an area. Well, what we can do is we can calculate the area, the volume of the revolved shape. So if you can imagine I was to rotate this curve, spin it around the x-axis, what type of shape would you get? It's kind of hard to draw, but if you could picture spinning it around, you'd get a cone. Yeah? Or, for example, here's another one. If I have a horizontal line and I spin it around, what would I get? A cylinder. If I spin it around the axis, I'd get a cylinder. Okay? What about if I had a curved shape like this? A sphere, yeah. It's a circle in 2 dimensions. A sphere, it would be in 3 dimensions. Okay, what about if I had a curved shape by the formula root x? If I spin this around, what shape would that be? It's kind of some kind of semicircle, some kind of truncated sphere. In fact, the shape that you get is the same shape as a satellite dish. It's not quite a sphere shaped. So this is the point I'm making. We can actually get the volume of irregular or peculiar shaped objects. So I'll do this one as an example first. We'll mark off 0 here and 1 here, and I want to get the volume of this peculiar shape. And try and draw it in 3 dimensions. So kind of looks like a satellite dish. It'd be the volume that a satellite dish could hold. So let's calculate this. The formula to get the volume is kind of similar to the area. There's only 2 things different about it. We still have to integrate from A to B, but instead of integrating f, we integrate f squared. And we multiply our answer by pi. This is the formula for volume. So you square, integrate, and multiply by pi. So let's try it out here for this one. If I square, what do I get? What is the square of root x?
X.
It's just x. And my limits here? 0, 1 dx. Alright, well this is actually easy peasy. What does x integrate to? X squared over 2. 0, 1. Well, obviously when I put in 0, what do I get? 0. Yeah, so I just need to really put in the 1. So this is pi over 2. That's the volume. So if I was using meters, for example, this would be pi over 2 meters cubed volume. Yeah? Oh, sorry. Mo, do you mind turning the light off, please? I forgot it was still on. I can zoom out. How's that? Okay, do you have that? Yeah? Right, let me give you one that's not too difficult. Can I scroll down? Yeah. So, let's say we have this shape here. It kind of looks like a cone, but it has its top cut off. So, you have this curve here. We'll say fx equals 1 plus x. and this is 0, and this is 10. Can you visualize if I rotate this around? I'll get a cone, but with the top cut off. Yeah? So I would like you to get the volume of this shape, please. So what's the volume of this truncated cone? Yeah?
So you get this times pi. So how would I simplify?
It's just going to be a decimal, isn't it?
Yeah.
Let's have a look now. Let's have a look now. Yeah? So the volume is pi, integrate from 0 to 10, 1 plus x squared. That's equal to pi, 0 to 10, 1 plus 2x plus x squared dx. Or you can actually use a substitution here if you like. You could have also said let u equal 1 plus x. That would have worked as well, whichever you prefer. Because it's only a square, I just thought just as easy to expand it. So this becomes pi x plus x squared, 2x squared over 2, which is x squared, plus x cubed over 3, 0 to 1. Now when I put 0 in, I obviously get 0, 0, 0. So I just need to put 1 in. So 1 and 1 is 2. 2.
It's 10.
It's 10.
Oh, sorry, it's 10 in this case.
Yeah.
All right. That's 110 and 1,000 over 3.
Yes.
110 and 1,000 over 3. Hang on, I can do this. I can do this. This is... don't help me. I won't learn if you help me. It is 1330 over 3.
Yes.
So 1330 pi over 3. That's the exact answer, which you can write as a decimal if you like.
Can you do it using substitution?
That's what I said.
Please do it.
I want to see how to do it using substitution.
Because
Yeah.
I got a different answer.
Yeah, okay. So for those people who want to see it done using substitution, at this step you say let u equal 1 plus x.
Yeah.
So du dx equals 1. So du equals dx. So this becomes pi integrate from 0 to 10 u squared du, which is pi u cubed over 3, 0 to 10, which is pi 1 plus x cubed over 3, 0 to 10. So if you put in 10, you get pi, and that would be 11. cubed over 3 minus pi over 3. So 11 cubed is 1331
Yeah.
pi over 3 minus pi over 3, which is 133 all pi over 3. What?
It's the same.
Yeah, that's what I'm saying. You can do it this way, you get the same answer. Yeah,
5 less steps.
wait a sec, yeah.
What if I skip the 2 steps after the x plus x squared and I
Shh, I can't hear her. What are you saying? Skip which two? The on the left or the right?
the left,
The left. This step?
no,
This step?
yes.
Skip it.
When I just replace the x with 10 and then I directly just turned 13.
Oh, you mean like go from here to the answer?
Yeah.
Ah, yeah, that's fine. That's fine. Okay, let me give you one to try now. Another one. Yeah. Okay. I'll just give you a minute if you need to write this down. Yeah? Scroll down. Scroll down? Not yet? Yeah? So, let's see. Here's a trickier one now for you to try. So, there we go. There's X, there's Y, and this shape here. This is a perfect, it's a perfect semicircle. And the formula I'm giving you is square root. The formula for this shape is square root 1 or squared is a constant minus x squared. Yeah, okay. And I want this volume. So obviously when you rotate it, what shape do you get? A sphere. Okay, try this.
Limits.
When you rotate, you get a sphere. Not telling you the limits. You'll have to figure them out.
One of the circle.
Limits is pi r squared.
The circle is two-dimensional. When you rotate it, it makes a sphere.
The limits are from 0 to pi r squared.
The limits are here, which is clearly not 0, to here. No!
Minus pi r squared to plus pi r
No!
squared.
Yeah, that's what that's.
Yes. The limits are the roots. The roots is where this equals 0. Oh, maths. Oh.
What are the fields of the B and K?
The what?
The B and K?
Oh, I just said it.
I wasn't specific.
The limits are the roots.
Oh, okay.
So if you need trouble starting it, the roots are minus or because that's when this will equal 0, which are the roots. So what you have here is sphere of radius or.
Would the roots be plus minus?
Yes. Now that was a waste of one of your questions because I said that like 3 times. How are we doing on this? care. It could be a decimal. Give it to me exactly. Whatever. If I don't specify, or if they don't specify in the exam, whatever. But if you want, I'll specify it for you. Give me the answer as an exact answer, no decimals. This is what you mean. Are you guys finished? No, well, come on.
How can you do this in SDA? Yeah, it should. R is a constant. R is not a thing. You cannot differentiate or integrate. It's a constant. I'm sorry. Okay. Why?
Yes.
Is this type of question common in the exam?
Which, this one?
Yes.
This type? 50%.
50?
It'd be half the time. Maybe a little less, actually. Maybe a little less.
Would it be worded in this one?
Yeah, because I've seen a question before where they say, here's a cone, and the base here, this point here is H0, and this point here is 0 or, get the volume. So I've seen that one before.
That's a good question.
No, it's a good question because you know what the answer should be before you start. So before I even start this, I know what the answer should be. What should it be?
4
It should be 4 over 3 pi r cubed because that's the volume of the sphere. Let's see if we get that. V equals pi minus r to r f squared. R squared minus x squared dx. That's equal to pi r squared x minus x cubed over 3 minus r to r. I'll put in r first and I'll get r cubed minus r cubed over 3. I'll put in minus r next and I'll get minus r cubed plus r cubed over 3. So now I get pi 2/3 r cubed minus pi minus 2/3 r cubed. 2 minuses make a plus. 2/3 plus 2/3, 4/3. 4/3 pi r cubed. So what you've done, actually, is prove the formula for the volume of the sphere. It's 4 over 3 pi r cubed. Yes? Did anybody get that? Yeah? Yeah? Down the back, did any of you guys get this? No? So, for the 2 lessons this morning, the previous lesson is very common in the exam, effectively 100%. This one here, more common lately. More common lately. I think it was in section B of last year's paper. Let's have a look, actually.
Can we solve that one?
Yeah, I'm going to have a look at it now. That's, maybe we will, yeah. Let's see. Maths for science. Maths for science, paper 2, or exam, semester 2, 17-18 version 1. Let's have a look.
Okay, let's see what you're doing.
No, I know. I'm trying to find it first, then I'll put it up on the screen. Yeah. Okay. Let me put this up. I'll switch it here. Okay, so last time when we were doing calculus questions, last time when we were doing calculus questions, a couple of these we did from section B, I think. This one here, quotient rule. This one here, chain rule. This one here is from semester 1, isn't it? How many integrations are required here? 2. What's the first integration? Well, I'd say the line. 0 to 2 under the line. And the next one? 2 to 4 under the quadratic. That one's actually nice because they give you the line, I think. Or did they not? You have to find the line. They give you the curve. Yeah, the L. And the L is a normal. So it's perpendicular to the tangent here. B we did was 5 marks. C we did it was 3 marks. D is the last part here of this calculus question in the exam. And that's what we're doing today. Where they give you a curve and it's rotated and they want the volume. Now what's nice is because there's a square root in the formula, it cancels out. So really, they're just asking you to integrate this. It's not bad for 4 marks. I'll let you try this now for a minute as a practice one. Can you see? Everyone see it okay? Yes. 4 marks. Yeah.
Which year?
Oh, it's the most recent one. 17-18 version 1, yeah.
6. Is it B6?
B4, last part. Here, it's B4D.
What's the answer?
I haven't got it yet, I'm doing it now. Did you just use your calculator?
Hmm?
Did you work it out?
Yeah.
Pen and paper?
Yeah.
Okay.
Plus calculation. It's the same formula for all volumes.
Yeah, it
regardless
is.
of
Yeah,
what-
yeah, yeah, yeah. Yeah, yeah.
It's 84 pi.
Hmm?
Is it? I'm doing it in my head here and I didn't get that. Which of course
I got 42.
I didn't get that either. Hang on, let me check something here. 72. 84 pi, yes?
Yeah.
Yes, that's what I got.
Yeah.
Right. So here's the answer on the screen here. The square root and the square cancel. And you forgot to integrate. Yeah, and you see, I knew you did it too quickly because it only took you 10 seconds to do. So you square root and square cancel, integrate. A key step in the integration question is integrating. And then you sub in 6 and 0. And I got the answer you got on the calculator, which is 84 pi. Now what do we think? Yeah? It shouldn't matter. The mode. You should always get 84 pi for this. 4 marks. It's okay.
But it's 3 steps.
Yeah,
The answer is.
that's my point. You're getting more marks than steps. Oh, so how would the marks break down? Let's see, actually.
Would they want us to write the formula?
Let's have a look. Let's have a look.
Seems dodgy.
Who's at the back? Could someone close the door? Who's closest? Looks like it's you. Oh no. Yes, I suppose you are closer. Okay. For last part. Right, let's have a look at the marking scheme here. So, you got 1 mark for basically getting the first line. And then 1 mark for the integration. 1 mark for substituting in and 1 mark for the answer. So if I switch back now. Basically I got 1 mark for writing this line down. 1 mark for having the integration here. 1 mark for subbing in the limits. And 1 mark for the correct final answer then.
So we need to show the subbing in.
No. If you, for example, skip this step
Yeah.
and just went straight from there to there,
Mm-hmm.
okay, and you got it correct, then let me go back to the marking scheme and show you. You see this little star here? Sorry, to be clear, you see the way this guy doesn't have a star?
Yeah.
What that means is, if this answer was right, you can assume they got this one right. Otherwise, how could they have got this right? And you can get the mark here for not writing this down. Now, you notice that this has a star on it. This means they cannot give you this mark unless you write it down, even if you got this right. And likewise here. They need to see at least this to get this mark, even if you get this right. So for this question, it would have been possible to drop this step and still get 4 marks. However, it's a bit risky because imagine you made a small mistake here. You know, let me switch back to this question here. Let me just give an example of what could have gone wrong in the exam. So suppose, let's just say I did something silly and I put the wrong number here, 2. Well then that means this guy here I would have as 12. Which means this answer here I wouldn't get 84, I'd get something else. Now how would the marks work? Well, I'd get 1 mark here for that formula. And I'd get 1 mark for this because it says here attempts to integrate. So I don't need to get all of this right to get the integration mark. If I get 1 of them wrong, I can still get my integration mark here. This, I would actually still get my mark here because I did sub it in correctly. Although I subbed it into the wrong answer, I did do the correct 6 and then 0. I would lose this mark here. I would get 3 marks. Now, if you skipped this step and everything else was the same, you would get 2 marks. Because you've not shown the marker that you've subbed in correctly. And the fact that you got the wrong answer here means they can't assume you subbed in correctly. Alright? So you can skip some steps, but it's not in your interest necessarily to skip the steps, unless you're confident you will make no mistakes in the exam. Okay? None of you should be this confident. Okay? So try to write the steps down. It might save you a mark or 2. Okay? Right, okay. So they're fine exam questions. I'll let you try them for a few minutes, yeah? No? Okay. Yeah, try them for a few minutes. They're pretty good for 4 marks.
Is this a general or just for these type of questions?
No, for all your questions, try not to skip steps.